Hi, Cameron. I hope all is getting better. I know you've had a rough couple days, and I'm sure you're ready to get out of the hospital, so hopefully today is the day. Anyhow, I sent Mom and Dad an email saying that what we've done in class today and yesterday was probably unnecessary for you to do, especially if you're not feeling the best. So I thought I would put together a video to cover the highlights of what we talked about yesterday and today so that you could just soak up the important stuff and be ready for Monday. Um, Yesterday, we went over the homework, that 1.1 packet, not the packet that Mr. Yoakum had cut up, if you remember that. We went over the 1.1 homework, that packet that I'd given you, and we talked about independent and dependent quantities. Remember that dependent quantities simply depend on the independent to happen. A lot of you all mentioned the cause and effect relationship. What causes the other to happen? We also matched the graphs with the appropriate problem situation. Um, if it was something where time continued but the distance stopped, let's say, for example, the girl who ran and then to school and then got caught in a cobweb and then she continued running, time is still ticking, but her distance stopped for that period of time in which she was um, caught in the cobweb. Okay, so time still goes because time is independent, but her distance, the dependent, she's going to be going, she's going to stop, and then she's going to keep going. So that's what we did yesterday. We matched graphs with problem situations and labeled their independent and dependent. Today, students had 22 graphs that they cut out, and I told them that there are no rules today. They simply had to match or sort these 22 graphs based upon their characteristics. You'll see on this page here, I made a Word document for you. Here are just a few of the graphs. They had 22 of these, just a few of the graphs they had, and they sorted, some of them sorted based upon curved lines, straight lines, dotted lines, solid lines, how many quadrants they took up. Everybody kind of had their own idea of how to sort. So we sorted and then we talked about how they sorted based upon what characteristics they saw. Just a few of the highlights, the need to know for Monday. Graph O is made up of a bunch of dotted lines. That means that the space between the dots is not a solution. Only the dots are solutions. The way I explain that today, it's kind of like thinking about rational numbers versus integers. Integers are all of the positive and negative whole numbers, 3, 2, 1, 0, -1, -2, -3. It doesn't include anything between 1 and 2. It doesn't include anything between 2 and 3. Whereas rational numbers are fractions and decimals and integers. So rational numbers take everything in consideration. So even if it's 1.5, that would be a rational number. 1.5 may be something that you see on a continuous graph. So if you'll compare O to H, O is discrete, made up of isolated points, and H is a solid line. That is discrete. I'm sorry, that is continuous. Okay, back up there. This here is discrete, and this one is continuous. Okay, we also looked at things that made curves, things that made V's. Curves are called quadratics. They make a U shape, either a regular U or like an umbrella. Those are quadratic functions. And D is an absolute value function. They make V's. G is an example of a piecewise function. This is kind of like saying that you started off running to school, then you stopped at the stop sign. Once cars had passed, then you started running back to school, where time would be your X and distance would be your Y. This is called a piecewise function because it's made up of pieces of linear graphs. And then the other thing that we talked about today was like graph N. If I were going to draw imaginary vertical lines through this graph, it would touch this graph in 2 points. A vertical line would touch it here and again here. Okay? Because it does not pass the vertical line test would be if a vertical line only touched the graph one time. For example, here, if I drew a vertical line and only passes that graph one time, that would pass the line test, whereas this graph would not pass the vertical line test because it touches 2 or more places. That would mean that N is not a function, whereas H is a function because it passes the vertical line test. Some highlights from today's notes that we took. A relation is the mapping between a set of input values. And let me see if I can't draw for you here. Input values are your X values. I'm not very good at this draw tool, so bear with me. These are your X values, and the output values, or the range, is talking about the Y values. So next week we're going to talk a lot about what does the domain and range cover, and we'll be talking about like where do the X values go and where do the Y values go on a graph. If we go back up to this graph here, let's pick a different one. This graph here. The X values are both positive and negative, but the Y values are only positive. There are no negative Y values. So the domain would be all real numbers because you can put any number in there. But the range is only going to be from 0 up. All numbers 0 or greater than 0. Okay, that's a little bit about the domain and range. Function is where each X has exactly one Y. We'll talk about that next week. Basically, if you apply the vertical line test, drawing those lines vertically through the graph, and it only touches the graph one time, then that passes the vertical line test, and that is a function. We know that discrete graphs are isolated dots, and continuous graphs are a smooth line or a smooth curve. It's a solid. And vertical line tests apply to discrete and continuous graphs. You may think they only apply to continuous, but they apply to discrete as well. One thing that I want you to ponder, and you may even want to pull up Google and do a little Google search, are all functions relations? Are all relations functions? So in this thought bubble here I have, so all functions are relations, but only some relations are functions? I guess it all depends on the domain and range. So the question I'm going to leave you with today, are all functions relations? Are all relations functions? So on Google, just Google function and Google relation and see if you can tell the difference between whether all functions are relations or are all relations functions. Feel free to call me. My number is 525-0111. Call me with any questions, but please don't get too in-depth because the kids did not get that in-depth. This was the meat and potatoes. This is probably even more than we covered in class. So if you have heard this and you watched this maybe 2 times, do your Google search. You'll be more than prepared for Monday. Okay? I wish you the best. Call me if you have any questions.